Welcome back to mean value theorem. All right, so we have f of x equals 2x plus 1 on negative 2 to 2. And we want to find the value of c that satisfies mean value theorem. All right, so we're going to integrate, evaluate, and multiply by 1 over the change on the interval. And that is going to give us the average value. Right, so and I didn't erase this because it's in your notes completely. So why should I erase it? All right, so I have 1 over 2 minus a negative 2. That'd be 1/4. We integrate 2x plus 1. That would give us x squared divided by 2. 2x squared divided by 2. So that would just be x squared. The 2's would cancel. Plus x, and we'll evaluate from negative 2 to 2. So we have 1/4 2 squared plus 2. Then we plug in the negative 2 and we subtract. So we have minus negative 2 squared plus negative 2. All right, so 2 squared plus 2 is 6. And negative 2 squared would be 4. 4 minus 2 is 2. So we have minus 2. So 1/4 of 6 minus 2 would be 1/4 of 4, or 1. So the average value for this function on that interval there is 1. If you set your function equal to the average, you can find out when the average occurs. This is a pretty easy solve, right? The average occurs at 0. So when x is, and of course, it's a line, right? That's our y-intercept. So at 0, we equal our y-intercept. I like this problem because it's so easy, it's easy to understand why this would be true, right? Of course, if our average for a function here is 1, that has to occur at 0. It's the y-intercept. Happens to be 1. Right? So nice, easy problem here. Let's do 2 more problems. This one is in your notes. And this is, I like this problem as well, just because we get a trig function here, and this one's a real intuitive one too. So it helps you understand the theory, which is the whole point. All right, so here we want to find the average value for f of x equals cosine x on an interval. So if you're asked to find the mean value theorem, if you're asked to find c that satisfies the mean value theorem for your function, it means they want to know when. So let's explain. Sometimes if you don't understand the question, it's hard to find the answer, right? So if the question says find c that satisfies the mean value theorem for a function here, it's asking you to find when the function equals the average value of the function. Because we know cosine, it takes on every value between negative 1 and 1, right? But when's it equal to the average on that particular interval? Let me add on a given interval. If you're not given an interval, you're pretty much done because you need to close the interval. Right, so here we want to find when does cosine x equal the average on the interval of negative pi to pi. So we integrate, evaluate, and multiply by 1 over the difference in our change in x. So we have 1 over pi minus negative pi. Evaluated from negative pi to pi, the integral of cosine x dx. We integrate whose derivative is cosine x? Of course, that's sine x. So we have 1 over 2 pi sine x, evaluated from negative pi to pi. All right, so now we just plug in and evaluate. So we have sine pi minus sine negative pi. All right, well, right here is pi, and sine is the opposite, which is the y value over the radius, right, over the distance. And well, that's 0 because the y is 0. So sine here is 0. And negative pi just goes, oh, I wanted to color them blue or green, just goes that way. And it's also 0. right, so we have 1 over 2 pi, 0 minus 0, times 0 minus 0, which is 0. All right, so when is cosine equal to 0? At pi halves and negative pi halves. All right, so that makes sense, right? Because between those values, right, sine is equal to 0, cosine is equal to negative 1 for both of them. So if we're going to take the average of those, if we're going to take the average, right, we're going to end up with nothing because we haven't moved anywhere. Right? So, of course, our average is going to be 0. And when would that occur? At pi halves and negative pi halves, because that's when cosine is equal to 0. Right? So I think this is a pretty easy problem to figure out, because essentially we've gone right back to where we started from. So there isn't any change. So if there isn't any change in your function, well, you're canceling each other out, right? We went one way and then we went the other way. And you can see that would cancel each other out and be 0. And so this is when cosine is 0, when the x values would be 0. So I think that's not too bad a problem. Let's do a little more complicated problem, and one that I don't have any word problem, because you might get a word problem, right? And one that it's not written in your notes. Right? The last problem in your notes is in the next podcast. In a certain city, the temperature in degrees Fahrenheit after 9 o'clock was modeled by the function T of t is equal to 50 plus 14 sine of pi t divided by 12. And we want to find the average temperature from 9 a.m. to 9 p.m. Right, so don't say 9 minus 9, oh, 0. What's the interval of time in this situation? Well, the interval is 12 hours. So be careful with time. Right? Don't think of it as just subtracting the hours. That would work great if we used military time, because the hours repeat, and 9 a.m. and 9 p.m. are very different. You want to find the total hours. So our hours this is 12 hours. What's the interval? 12 hours. All right, so now if we want to find we got to find the average temperature, and then let's find out when that average we're going to find out, well, we're going to find the average temperature, and I think we'll call that good, because, well, I don't know, maybe we'll find out when. Let's see how long it takes us to find the average. All right, so let's do a little bit more than the problem if we find out when. All right, so we want to find the average temperature, and this is not going to be a pretty number, so we'll compute to 2 decimal places. So to find the average, that's just going to equal, let's give it context, average temp is going to equal the integral of 50 plus 14 sine pi t divided by 12 dt from, so let's call this 0 to 12, not 9 to 9, because that doesn't really have any meaning, right? 12 hours is our interval. If this is 0 hours, this is 12 hours later, all right? That just makes a lot more sense, right? Because otherwise you have 9 minus 9 is going to be 0, and that won't work out very nicely at all. All right, so average temperature, we're just going to, oh, I almost forgot. So busy setting up the interval, I wanted to not leave myself space to do this, 1 divided by 12. All right, so we're going to multiply that by 1 over 12. That's our change in time. And that's our average temp. Right, so these aren't very difficult. All right, you're just going to integrate, evaluate, multiply by 1 over the change. So that's 1/12. If we integrate, we have 50t plus, okay, so now we might want a u to u substitution. So let's split the integral up, because we're going to need a u to u substitution for the sine part. So it would make real sense to do that right off the bat. So u is equal to pi t divided by 12 du dt would be pi 12ths. I'll have a pi 12ths. So du, I should say 12 divided by pi du is going to be equal to dt. Right? So that will replace dt, and this will replace that, and then we'll be able to integrate. So here we have a little substitution. And the 50 is fine the way it is. So now let's rewrite that. So 0 to 12, and this would be 50 dt plus, and 14 can come out. So you've got 14 times 12, and that's 160, is that 168? Divided by pi. Yeah. Yes. All right. And that would be sine u du. And maybe, should we change? Nah, we'll just substitute back. We've changed them so many times. Let's just substitute back on this one. There we go. Equals 1/12. So now we'll integrate and evaluate. All right, so this is going to be 50t. And because I didn't change, right, I don't have to worry about changing I can just write it all together and put the limits of integration at the end. So we have 50t, and then we have to add, I don't really need a parentheses there, so let's just take that out. 50t plus 168 pi, and whose derivative is sine? That would be negative cosine, right? Because derivative of cosine is negative sine. There's no negative there, so it has to be negative cosine. And let's just substitute back instead of writing cosine u and then plugging back in. Let's change that back to in terms of t. So this would be pi t divided by 12, because that's what u was, or u is. And we're going to evaluate that from 0 to 12. All right, not so hard, right? All right, so we have 1/12. So I got to plug in the 12, and I got to plug in the 0. So I have 50 times, we have 1/12 times 50 times 12 plus negative 168, oops, wait, yeah, I'll plug it all in, yeah. I don't want to break this up, never mind. 168 pi cosine, oops, putting in the 12 for pi. Pi times, actually let's put that as 12 pi, that looks weird, pi 12. 12 pi divided by 12. Well, that's just pi, right? And then we have to subtract, because this is already a long enough problem. Let's see if we can write a little smaller. 50 times 0 plus negative 168. My shadow is blocking me. Pi cosine, and that would be 0. Well, if I have 0 pi 12ths, that's just going to be 0, right? That's just 0. Right, so that saves us a little bit. You can just simplify right there, because that's pretty easy to figure out that you multiply by 0, you're going to get 0. So 50 times 12 would be 600 plus, and so now we have, I don't want to extend the page too much. Let me squeeze in here cosine pi. Right, so cosine pi we just said that on the last page, is -1, right? So now this would just be -168 pi times -1, right? Which is going to make that positive. So that's just 168 divided by pi. And actually that looks messy. So let's see if I can, if you're okay, we're just going to replace that cosine pi part. All of this is just -1. So let's just plug in the -1 down here. -168 times the -1 is going to be positive. Everyone okay if I just do that so I don't have to extend this page too much? Have you write a whole lot of stuff. That's a pretty easy thing to understand, I think. So then we have 0, no point in writing that. And then cosine 0, this over here is just 1. Right? At 0, cosine is 1. So now we have minus a negative. That's going to be plus 168 pi. Oh, excuse me, 168 over pi. And this is the most annoying arrow ever. Hopefully everyone was clear on that computation. All right, so now let's clean this up a little bit. All right, so this is going to be 1/12. And actually, well, I'll add those two and then I'll distribute. 1/12 600 plus, so that would be 336. I believe that's 336. Right, 336 pi, yeah. I keep saying pi, but it's over pi. All right, so now we'll distribute, and obviously we'll just get the exact answers, then we'll continue on. So 1/12 of 600, all right, that's going to be 50. And that would be plus, and that's going to be 28 over pi. All right, so that's what the average value is. If we get the decimal equivalent of that, that is 58.91, 2 decimal places. Right? So that's what the average temperature is. If we wanted to know when, I'm going to extend the page. We're not going to solve it out. We'll just set it up, right? If you understand how to set it up, the rest is just plug and chug. All right, so using mean value theorem, sometimes you may just be asked to set up the problem. That shows you understand it without having to necessarily solve it out. So if we set 58.91 equal to our function there, which is 50 plus 14 sine pi over pi t divided by 12. Right? If we set that equal to and solve for t, we will find out when this occurs. Of course, my last word, the last word does that to me. Oh, just deal with the line. I'll erase it later. Right? So we're not going to actually solve it out. But so long as you understand that if you set your function equal to the average value, you'll find out when our actual temperature was the average temperature. What day was that? You know, or excuse me, not day. What time was that when we were 58.91 degrees? Right? Not worth solving out the equation. It's not that important, so long as you understand how to get the value. Okay? that's the end of this lesson on average value and mean value theorem. If you have any questions, let me know, and I hope I've clarified this concept for you. I have, and actually I said that's because I shouldn't say this is the end because I have one more podcast. However, I've already made that podcast. So enjoy the next podcast when I go over an applied problem using a table of values. Bye for now.